So for the last class, we have stopped here. That is principle of entropy. Principle of entropy and application of principle of entropy or entropy principle. Okay, is for isolated system. Isolated system
പ്രസന്റേഷൻ
for an
കാണുമല്ലോ.
കാണത്തില്ലേ ശരി ശരി. Okay. So principle of entropy is based on isolated system. For an isolated system, there is no heat transfer, therefore Q value equal to 0, therefore dQ equal to 0, therefore dQ by T, that is entropy value, total ds isolated is equal to 0, not equal to 0, it is greater than or equal to 0, that is entropy principle. Okay, and for this session, I'm taking about entropy generation. Entropy generation. So what is an entropy generation? So how we can increase an entropy in a system? Entropy increase. Entropy generation is the topic. Entropy generation in a closed system and open system. So what is entropy? How we can increase a particular value of increase of a particular value of entropy of a system? To increase, only two methods to increase an entropy of a system is, first one is to increase the heat transfer rate. Heat transfer rate, along with the heat transfer rate, the entropy will also will increase. Okay, when heat increases, when temperature increases, entropy also increases. So first, only one method to increase the entropy of the system is to increase the heat transfer rate. First one. Second one is to add or increase the dissipative effects. What is dissipative effects? We have studied in last session that previous session that dissipative effects, friction, viscosity, etc. That type of dissipative effects or something called irreversibility. Irreversibility or dissipative. The only two methods to increase the entropy of the system is, first one is to increase the temperature or increase the heat transfer rate. Heat transfer rate. Second one is to increase the irreversibilities. Irreversibilities or dissipative effects. Dissipative effects. So this kind of increase in entropy, due to irreversibility or dissipative effect is known as entropy generation. Okay, so by notation you can say that we know that ds equal to dq by t. ds equal to dq by t. Okay, that is entropy, general equation for entropy, that is ds equal to dq by t. For a reversibility or dissipative effects, we can say that ds equal to dq by t plus di of s. di of s. ds equal to dq by t plus di of s. This dis is termed as entropy increase due to external heat generation. Sorry, not external heat generation, it is due to irreversibility. dq by t is the term related to external heat generation. Right? dq by t is the term related to external heat generation. dq means change in heat transfer divided by absolute temperature. That is the entropy increase due to external heat generation. And plus dis. dis is the entropy increase due to irreversibility or dissipative effects. And this kind of particular entropy generation due to effects of irreversibility or effects of dissipative effect is known as entropy generation. Okay, an additional energy or additional particular increase in entropy that comes into a system due to irreversibility or effective dissipative effect is known as entropy generation. This is for closed system. Okay, this is for closed system. So what happens to open system? As I explained, the value or the term entropy change in closed system and open system. What was the change there? For an open system, we only write an equation only, right? For a closed system, we derived an equation and thereafter we derived a particular values for constant pressure process, constant volume process, isothermal, adiabatic, polytropic, etc. So for an open system, we only write a notation only. What was the difference between that particular open system and closed system? That is, in an open system, there occur a mass transfer also. Right? Closed system only heat transfer rate only energy transfer is taking place there. But in case of open system, there is a transfer of heat and mass also. Okay, there is a mass transfer also. So here also entropy generation in closed system simply is that ds equal to dq by t plus ds, and ds is known as entropy energy due to irreversibility. And also we can write this equation as, we can term this equation as entropy generation that particular DAS. So we can write entropy generation as S generation equal to ds minus dq by t, right? ds minus dq by t, or we can write s2 minus s1 minus dq by t is the S generation. What is the equation for that entropy generation? That is entropy generation equal to change in entropy plus or minus change in entropy minus entropy transfer. Okay, entropy generation equal to change in entropy S2 minus S1 minus entropy transfer dq by t. That is the S generation equation for closed system. For open system, there occur a mass transfer also, m term. So for the last previous entropy for a open system, we had derived that there is a extra term. What was extra term? S into m, right? S into m, that is S into m ചെറിയൊരു s ചെറിയൊരു m ആയിട്ട് തോന്നുന്നു അല്ലേ? That is particular small s and m, that particular entropy and mass product S into m. Here also there occur a particular change, that is a mass transfer entropy change കൂടി ഇവിടെ add ആകുന്നുണ്ട്. Okay, S generation, the particular equation will become like, you can write the particular equation as S2 minus S1 equal to, for an open system, there is mass transfer also. So the equation we can tell as S2 minus S1 equal to, that is ds equal to 1 by m dq by t plus S generation by m, the whole time divided by mass volume. Okay, change in entropy. So S generation can be written by combining the particular equation into a other form, and S generation into a side, and total all the other part into other side, we can generate an equation for S generation. So in this case of particular open system, there occur a mass transfer also. So the equation becomes a particular mass transfer value will also become into equation is we can write as 1 by m. 1 by m എന്നുള്ളത് അത് സ്പെസിഫിക് ആയതുകൊണ്ടാണ് നമ്മൾ അടിയിലേക്ക് ഒരു ഡോട്ട് ഇട്ട് കൊടുക്കുക. സ്പെസിഫിക് മാസ്, ദാറ്റ് ഈസ് അതൊരു ഡെറിവേഷൻ വരുന്നുണ്ട്. ഡെറിവേഷൻ വന്നാൽ ദാറ്റ് ഈസ് എ പെർട്ടിക്കുലർ സ്പെസിഫിക് എൻട്രോപ്പി പ്ലസ് സ്പെസിഫിക് മാസിന്റെ മൾട്ടിപ്ലിക്കേഷൻ വന്നിട്ട് ഇത് more and more steps we can arrive this particular equation, that estimation equal to 1 by m and dq by t plus S generation by m. Simply we can say that by avoiding the open system, what is entropy generation? We can simply say that entropy generation is a particular value or another increase of entropy due to irreversibility or dissipative effects. Okay, and we can write the equation as ds equal to dq by t plus dis. That is dis is the entropy, additional entropy increase due to irreversibility, or we can quote as entropy generation or S generation equal to S2 minus S1 minus dq by t. Okay, that is the particular term related to entropy generation. And the last topic related to entropy is, entropy and disorder. So what is a disorder? Disorder means simply opposite of order. So in a particular gas flow, in a particular system, there will occur a orderly flow and disorderly flow. So many energies are occurring in a particular system, right? So many energies, like kinetic energy, potential energy, heat energy, mass energy, etc. So many energies are occurring in a particular system. Like kinetic energy is due to the movement of the particular molecules, right? And potential energy is the stationary type molecules energy, potential energy. And heat energy is the energy occurring due to the transfer of heat between the molecules. Molecules collide with heat transfer energy and heat energy. Okay. And heat energy occur due to disorderly motion of the particular molecules. Heat energy occur due to the disorder movement of particular molecules. When a particular molecule move only in a straight path, only in an orderly motion moving, and there are no collision between each other. Okay, there are only collision, only moving in a particular normal path. All molecules are moving in a certain orderly path. There will be no collision. All will move in a particular uniform motion, a particular uniform velocity, and particular uniform direction. There will be no collision, and there will be no collision means there is no kinetic energy. There will be no particular heat energy, right? Only heat energy occur when the molecules move in a disorder flow, and when collide each other, and particular after colliding produce a particular energy, and energy produced in a system, right? So every heat energy in a particular system is produced only because of a disorder movement of molecules, not in an orderly motion of molecules. Disorder motion of molecules. So we can convert a orderly motion to disorder motion very quickly. Change we can disturbance it will move in a disorder flow. So it is very difficult to change a disorder motion into a order motion. We cannot change a disorder motion into a order motion. Take an example of particular free expansion or free expansion of molecules. That is, when partition is removed, all the gas will expand to this vacuum. Okay. Initially, when it is in a particular system, that is, all the gas are enclosed here, and this is a vacuum. It is kept in a orderly motion. That particular molecules are not moving either, or moving in a particular orderly motion. Okay. When partition is removed, all the gas came to expand the particular vacuum. All the gas here came across and mix with the particular vacuum and will collide each other and will cause a system. Okay, it occurs a disorder motion, and we cannot convert this particular disorder motion into a orderly motion. We can convert this orderly motion into disorder motion very quickly, but we cannot change this disorder motion into a orderly motion. Okay, we cannot convert this particular disorder motion into a orderly motion. The very big example for this type of disorder motion and orderly motion conversion is the mixing of two fluids. When two fluids are mixed, the disorder motion will increases. The disorder motion of the particular molecules increases than they are leaving it separate. Movement disorder motion. Okay, a perfect example for the particular. So how we can relate this entropy and disorder? How we can relate this particular entropy and disorder? That is the thing we want to focus. Disorder flow and water flow. So take a closed system or an isolated system. Take an isolated system. In an isolated system, there is no transfer of heat and mass energy. To system and surroundings. Take an isolated system. There is no exchange of heat or mass to the outside system or outside surroundings. The only thing happening inside is change. It is not coming outside. Okay, in isolated system. When we apply heat to isolated system, okay, take a pressure cooker or anything. Take a particular. Can we apply heat to a pressure system? The heat inside the particular system increases. Heat increases, and the movement of the particular molecule goes on increases. Heat when heat is applied, the particular movement of the particular molecule increases, and the particular molecules move in a disorder motion and collide with each other and produce some energy. Right here, when heat is applied to isolated system, the inside molecule absorbs heat energy and will move faster and collide with each other and produce some energy, and hence entropy increases. When temperature increases inside isolated system, and particular the molecule move in a particular disorder motion and they collide with each other, and the energy increases and the entropy also increases. Okay. Take an example for isolated system. Isolated system, when heat is applied, temperature increases inside the system and entropy increases. Entropy also increases. So here, disorder motion of the particular molecule tend to increase the entropy. Disorder motion of the particular molecule and the collide each other tend to increase the value of entropy. Okay. So all irreversible process always tend to have a greater disorder. All irreversible process. Here example is this free expansion is a irreversible process, right? This process is a irreversible process. We cannot change the particular system into normal one without any external force. So it is a irreversible process. So all irreversible process is a disorder one. Is a disorder one. അതൊരു particular ഓർഡറിലാണ് പോകുന്നതെങ്കിൽ നമുക്ക് ഒരിക്കലും തിരിച്ചു കൊണ്ടുവരാൻ പറ്റും. Disorder. All irreversible process disorder one. Okay, and all isolated system possess a greater entropy. It's a simple theory that all isolated systems possess a higher degree of entropy. All isolated system, because there is no transfer of heat occurring here, there is no mass occurring here to the outside surroundings. So when the heat is applied, the particular kinetic energy of the molecule increases and they collide each other and energy produces, and thereafter entropy also increases. So all isolated systems possess a higher degree of entropy, and all irreversible possess a disorder. So we can relate both theory together. And we can say that entropy and disorder has a particular relation. Entropy and relative proportional to disorder. Entropy is relative proportional to disorder. That is, every reversible process a disorder. And reversible process, we can take it isolated case. We can take it in isolated case, that is free expansion. And here, when disorder increases, entropy also increases. When disorder increases, entropy also increases. From here, we can derive a new definition for entropy. That is, an entropy of the system can be also be defined as measure of degree of molecular disorder existing in the system. അതാണ് എൻട്രോപ്പിന് വേറൊരു definition. Entropy is the measure of degree of molecular disorder. In a system. That is, when disorder of molecular motion increases, the entropy also increases. Okay, disorder motion of molecule increases, equal to entropy increases. That is, entropy is directly proportional to disorder. That's the relation. Okay, then vice versa. When disorder decreases, entropy decreases. Disorder motion decreases, entropy also decreases. Okay, that is a new definition for entropy. That is, entropy of a system is the measure of the degree of molecular disorder in a system. It is a measure of degree of molecular disorder in a system. How much disorder increases in entropy also increases. Okay, these are all the particular terms related to entropy. Okay, the entropy section. Okay, then there are so many problems in your textbook. Right? There are so many problems to do in your textbook related to something entropy of closed system, entropy of open system, or something related to entropy change in entropy, heat transfer rate, canonical erode efficient, which I will give you as a PDF. And also thereafter, if you need, I will make a particular video of the particular solving of particular problems if you need. Okay, so we can move to your next major topic, the third last topic of this module, that is available energy. available energy. Okay. Available energy is simple. We can call it as logical challenge. Available energy is kailulla energy. Available energy. Okay. Available energy can be simply stated that a maximum amount of energy in a particular system or in a particular engine, and which can convert into work. We can convert it into work. So we studied about particular heat engine, right? Heat engine, that is absorbing heat from a source, and then engine, and then sink, right? That is Q1, Q2, heat engine, right? And additionally, work is taking outside. Okay, which we have studied in our second law of thermodynamics. In our third module, that particular source is giving a particular heat to a engine is absorbing heat from a particular source at a T1 and converting this particular energy into work, and remaining heat Q2 is released into sink at a lower temperature T2. And here we can state that an available energy can be defined as the maximum amount of energy at which we can convert it into work. Okay, available energy is a maximum amount of energy which we can convert it into work. ഇവിടുന്ന് Q കുറച്ച് വർക്കായിട്ട് പോകുന്നുണ്ട്, ബാക്കിയുള്ളതാണ് താഴോട്ടേക്ക് പോകുന്നത്. സോ എത്ര എമൗണ്ട്, മാക്സിമം എമൗണ്ട് ഓഫ് എനർജി Q1 which we can convert it into maximum work is known as available energy, and the rest of the energy which we release into sink is known as unavailable energy. So there are mainly two types of energy in a particular system, that is available energy and unavailable energy. Available energy is the maximum amount of energy which we can convert into work, useful work, and the remaining energy which we are releasing to sink is known as unavailable energy. Okay, so we can, so initially giving heat is Q1. Q can count as available energy plus unavailable energy. That is, available energy is ഇങ്ങോട്ടേക്ക് പോയത് മാക്സിമം കൊണ്ടും എക്സ്ട്രാ താഴോട്ടേക്ക് പോയത്. സോ ടോട്ടൽ Q1 ആണ് കൊടുക്കുന്നത്, അതാണ് വർക്കായിട്ട് പോകുന്നതും ബാക്കി താഴോട്ടേക്ക് പോകുന്നത്. സോ വി ക്യാൻ കോൾ Q1 total Q1 equal to available energy plus unavailable energy. Okay, that is maximum amount of energy which we can convert it into useful work is known as available energy, and the rest of energy which we are releasing to sink is known as unavailable energy. Okay, means what is availability? Available energy and availability is a very important term. Available energy and availability. So availability is the maximum amount of work. Also again availability question, availability, maximum amount of work which we can obtain from a system at any state P1 T1 which operating with a reservoir at a constant pressure and temperature P0 and T2. P0 and T2 in its initial as final condition, that is atmospheric condition, and at any engine or any reservoir working at the initial temperature of P1 T1 and producing a work, and the maximum amount of that work we can take use is known as availability of maximum amount of work. Okay, so available energy and availability both are theoretically same. Available energy and availability. Available energy is the maximum amount of energy, and availability maximum amount of work which obtained. Okay, available energy is Q1, maximum amount of energy that we can convert into work, and availability is the maximum amount of work obtained. Okay, so I said that Q1 equal to available energy plus unavailable energy. Okay, so maximum work equal to available energy. So both are equal. maximum work obtained equal to maximum energy which will convert into work equal to ഇവിടെ A എന്താണ് QI minus Q1 minus unavailable energy. Q1 minus unavailable energy. AE equal to Q1 minus unavailable energy. Okay. Q1 minus unavailable energy. So we can use this particular notation to derive a particular equation for available energy and unavailable energy. Okay. Do you know that when a particular source is at temperature T1, source is at temperature T1, and there is an engine and sink is at temperature T2. Okay, and work is obtained. Here it is Q1, here it is Q2. Q1, Q2, work is obtained, source is at temperature T1, sink is at temperature T2. Okay, then we can say that efficiency of a particular engine equal to a reversible engine equal to 1 minus T2 by T1. 1 minus T2 by T1. നമുക്ക് അറിയുന്ന equation 1 minus T2 by T1. And for this available energy, our theory states that a maximum work want to be obtained, like maximum energy and maximum work want to be obtained. So here it can be written as efficiency. We can written as W by Q1. W by Q1. W by Q1 equal to 1 minus T2 by T1. That's the equation. W by Q1 efficiency. So to obtain W max, it is W max to obtain W max at a temperature T2 by T1 is there. So T1 is here. Q1 is the initial amount of heat we are supplying. Unavailable energy is related to Q2. Q2 is related to unavailable energy. So to obtain maximum amount of energy, that Q2 want to be very small. T2 in a value, value ചെറുതായിരിക്കണം. That means maximum amount of heat must be transferred as work. Maximum amount of energy must be transferred into work. So in order to obtain the maximum amount of work, the value here released into sink will be very less. That T2 value will be very low. So to obtain maximum work, T2 want to be minimum. T2 want to be minimum. T2 minimum means the minimum temperature which the energy releasing is atmospheric temperature. ഏറ്റവും ചെറിയ ടെമ്പറേച്ചർ ആണ് അറ്റ്മോസ്ഫിയർ ടെമ്പറേച്ചർ ആണ്. അതിന് താഴെ വേറെ ടെമ്പറേച്ചർ ഇല്ല. ഓക്കെ, ഇനി T1 and T2 is there. T1 is the higher temperature, T2 is the lower temperature. And maximum or minimum amount of T2 ഏറ്റവും ചെറുതാവുന്ന എപ്പോഴാണെന്ന് വെച്ച് കഴിഞ്ഞാൽ അത് T2 equal to T0 ആകുമ്പോഴാണ്. ഇറ്റ് മീൻസ് അറ്റ്മോസ്ഫിയർ ടെമ്പറേച്ചർ ആകുമ്പോഴാണ് ടെമ്പറേച്ചർ ഏറ്റവും ചെറുതാവുന്നത്. മിനിമം ടെമ്പറേച്ചർ വിച്ച് എനർജി ട്രാൻസ്ഫർ occur is the atmosphere temperature. Okay, obtain maximum work T2 minimum and T2 equal to T0 ആകുമ്പോൾ T2 equal to T0 ആകുമ്പോഴാണ് T2 minimum ആകുന്നത്. T2 minimum ആകുമ്പോഴാണ് this particular W equal to W max ആകുന്നത്. So we can say that W max equal to here W max equal to 1 minus T0 by T1, T2 T0 into Q1. W max equal to 1 minus T0 by T1 into Q1. T0 by T1 into Q1. Okay. And let us take, this is the W max equation. W max equation. Please write down the particular equation and put it in a box. And there is a small derivation. Small derivation means 3 or 4 line derivation is there. 3 or 4 line derivation is there to obtain the value of that available energy and unavailable energy. So figure which we can do it in your next class, which we can complete in your next class. Okay, ഇതുവരെ കംപ്ലീറ്റ് ആക്കാം. W max value അല്ല നമുക്ക് വേണ്ടത്. We want to obtain the value of available energy and unavailable energy. Available energy and unavailable energy. And here W max and equation will be in which we want to draw a particular figure and to explain a particular process happening inside a heat engine, and a 3 or 4 line derivation is the simple derivation is the to obtain the value of available energy and unavailable energy. Okay. Thereafter, we want to know what is the equation for a available energy for a closed system and open system. അതൊരു അരപ്പേജ് കാര്യങ്ങൾ പറയുന്നു. Equation for available energy in a closed system and open system. Thereafter, we want to talk about irreversibility and some problem is there, and we can wind up this particular module in our 2 or 3 sessions. We can wind up this module 30 more or less 2 or 3 sessions. So, we punctual in a class.